Hello, my name is Muhammad Hassan Hafiz bin Jamaluddin. My metric number is PB21035. Today I would like to present topic pressure measurement, capacity sensor against strain gauge. So before I start, here as you can see the list of the content about our topic today, we can talk about introduction, the capacity sensor and how it works. Also the application of capacity sensor, related equation about capacity sensor and the characteristic about capacity sensor. Also about strain gauge also, how it works, how the application and how the related equation and the characteristic and comparison about these two tensors. So the introduction. So about pressure measurement is fundamental aspect of modern technology in enabling precise monitoring and control in a wide range of applications. From industry process to medical device, the capacity sensor is the device that measure pressure by converting changes in pressure into changes in capacitance. They are often used to measure gas or liquid pressure in various applications, including jet engine and car tires. As you can see here, the capacity sensor so measure pressure by converting changes in pressure into changes in capacitance. So when apply the pressure for the capacitance 1 and capacitance 2, the changes of the capacitance will produce the output for the for the capacity changes. So about the strain gauge is measure pressure indirectly by detecting changes in electrical resistance. It's a material deformed under stress, making the ideal for high pressure and structure application. So as you can see the diagram above, as you can see gauge backing, resistance coil, and strain direction. So if pressure is directly by when pressure is directly applied by the gauge backing, it will detecting changes in electrical resistance as the material deform. So here about how actually capacitor sensor work. So when pressure is applied to the diaphragm of a capacitor sensor, it will cause the diaphragm to move. This diaphragm acts as a one plate of a capacitor while a fixed electrode serves the other plate. So as you can see in the diagram, it has a diaphragm, capacitor plate, pressure port, pressure bellows, and insulated send-off. So as the diaphragm moves closer to or further away from the fixed electrode, the capacitance between two plates changes. As you can see here, the capacitor plate, it will directly changes when the pressure push the diaphragm to the closer or the further away. Then these changes in capacitance is directly proportional to the applied pressure. So the sensor measures this capacitance variation and convert it into an electrical signal, which is then interpreted as a pressure reading. So uh, the electrical signal is directly changes by the capacitance variation. So as you can see, when the diaphragm move close to capacitor plate, there it will show the output electrical signal. Same goes when it will further away. So then here is the application that used for the capacity sensor, tire pressure monitoring system, engine management system, and braking system. As you can see in the picture, the capacity sensor for the tire pressure monitoring system, it will send a real-time data to the vehicle sensor center, ensuring proper inflation. So it will can help to improve overall driving safety. Also, engine management system, it will measure manifold air pressure, sent to the engine control unit (ECU), then optimizing fuel air ratio for better engine performance. Also, in the brake system, also it will help to monitor hydraulic pressure in advanced braking system like ABS to maintain consistent braking performance. So here is the capacity sensor related equation. As you can see in the first picture here, it will show Epsilon R is the electric constant to material between plate. Epsilon naught is the electric constant. A is the area of the plate, and D is the distance between the plate. So here is the dynamic equation. C equal to epsilon R, epsilon O, epsilon naught, A over D. So here is the example problem. As you can see, in the capacitor has following specification. The plate area has given, the distance has given, the dielectric also is given to the equal to 4, and permittivity of free space epsilon naught is fixed. As you can see, here's the value. So the question is about to calculate the initial and final capacitance. So first we have to calculate the first calculate initial capacitor. As you can see, we use the dynamic equation and include all the value given, and then we get the answer. Also in the step 2 also we use the same formula, dynamic equation for the final capacitor. As you can see, we get the final answer is initial for the initial capacitance is 7.08 and the final capacitance is 7.05. So here is the characteristic about capacitance. It has a high accuracy, especially in low pressure application. As you can see, example I given about the pressure tire. And then the measurement range suitable for low moderate pressure range. Also, its size has compact size allow for easy integration in tight space. And the cost effectiveness is typically more cost effective compared to other pressure sensor. So the also about the durability is robust but can affected by environment factor like temperature or humidity. So here I will tell about strain gauge. Strain gauge uh, like what stretches or compresses when the material to which it attached stretches or compresses. Then the strain gauge length varies and its cross-sectional area shrink. This modification modifies the grid electrical resistance based on the gauge factor, which is a material property. So then the strain gauge length varies and its cross-sectional area shrink. This modification modifies the grid electrical resistance based on gauge factor. So then the circuit of the strain gauge connected to typically a Western bridge. As you can see here, the picture given about uh, Western bridge, we convert to the simple simple circuit and then transform into electrical signal voltage by the circuit. Then the electrical signal is processed and converted into a strain value, which can be used to calculate stress, force, or pressure depending on the application. As you can see here, in the strain gauge, it has a longitudinal strain and transverse strain. So when the pressure applied to the surface of the plate, it will uh, it will apply to the longitudinal strain and transverse strain. So from the pressure also will convert into electrical signal by with the Western bridge of the circuit. Then and here is a application of strain gauge used industrial pressure transducer, medical pressure measurement, and automatic and pressure sensor. So for the medical pressure measurement, strain gauge is in medical device like a blood pressure monitor and respiratory pressure sensor. Also for the automotive pressure sensor, it used in tire, fuel, and oil pressure. For the industry pressure, it used to for measure gas or liquid pressure, like oil and gas. So here is the simple process for from the load. The strain gauge we it will convert to strain gauge transducer and then goes to tensiometric amplifier and it will show the data processing equipment. So here is strain gauge related equation as you can see here. The general equation is given for the circuit. Voltage output is equal to VA minus VB. Then we use a divider rule equal to R2 over R1 plus R2 multiply V in minus R4 over R3 plus R4 multiply V in. So here is the simple example problem as you can see. It has given a gauge vector, nominal resistance, and applied strain. So we use this formula, gauge vector formula. The change in resistance due to the strain. So here is how we calculate the first step in change in resistance. We get delta R is equal to 0.126 and the R new is equal to R plus delta R. So as you can see, we just add the R new to the delta R we get. This changer also in resistance can be used in within bridge circuit to measure strength accurately. So it's from another formula when they're given the resistance, the value of resistance, and given the voltage of the input. So here we can also calculate by the using this formula to get the voltage output produced. So here is the characteristic of strain gauge. It has a high accuracy in measuring small pressure changes, essential for precise control. Also, the durability is robust and durable, but may be sensitive to temperature and environmental factors. Also, the cost effectiveness is very economical compared to other pressure technology like a piezoelectric sensor. So it has power consumption, low power consumption, making it suitable for energy efficient application. So yes, about the comparison about the sensor, capacitive and strain gauge. Function of the capacitive sensor measure pressure by detecting changes in capacitance, but for the strain gauge, it measure pressure by detecting strain due to deformation. Also, the size for capacitive sensor is compact and suitable for tight space. For the strain gauge, it is small and adaptable to various configurations. Also that sensitivity about the capacitive sensor is sensitive to change in dielectric properties, but for the strain gauge, it's sensitive to strain caused by the pressure. Then here about the conclusion about test to two sensor, capacitive sensor and strain gauge. So as you can see here, both capacitive sensor and strain gauge are effective for pressure measurement, but serve different needs. As an example, capacitive sensor are highly accurate for low pressure application. For the strain gauge is versatile, offering high sensitivity across a broader pressure range. They are well suited for industry, automotive, and medical application where detecting mechanical strain is critical. So the choice depends on the specific pressure range and application requirement. Okay, thanks for watching.